So yeah, I am Matthew Flatt. I work in the Sharks team in Redgate Foundry. Chris Heppell will also be along shortly, hopefully, to do his part of the session in the second half. But today we wanted to give you a view of what the Foundry division does in Redgate, how we kind of work, how the projects go through different stages, and then show you a couple of the active projects and tell you how you can kind of get involved. And we'll have plenty of time at the end for any questions anyone has. So in terms of the Foundry team, we are basically the early stage research and development team at Redgate. And what we do is we take kind of these early stage projects or ideas for potential projects or products, and we try and investigate those through different stages and try hopefully to kind of push those through to products or features available in the tools for all our users. And throughout the kind of thousands of conversations that people have with Redgate employees throughout the year, whether it's with a salesperson at kind of the feedback or questions at a talk like this, or support, user voice, anything like that, they all kind of feed into some insights, and then we can decide from there what might be interesting projects to kind of work on in the upcoming months or years. And we typically try to look at what's important to our users or future users right now, so what's going on and what challenges they're facing. What will be important for them to be looking at next? So how is the environment or the role changing, which they might need some additional support for? And also what are the industry trends as well, which are going to affect everything we do. So I want to keep aware of those. And when a project comes into Foundry, it generally fits into one of three stages. And me and Chris work in the Sharks team, which is a team which spans both stage 1 and stage 2. So we work on all the projects within there. And then stage 3 is slightly later on. So stage 1, we're mainly doing a lot of research into the problem space, trying to speak to any users which might be experiencing these problems, speak to experts, go to conferences, read content and that sort of thing to get a better idea of the idea that's come through in the pipeline, whether it's something we can add value to for our customers and potentially get some new customers as well. Once we've done that and we've kind of done some validation that that's a good idea and something we should investigate further, then move into stage 2, where we generally build some sort of prototype. Maybe that's just designs, maybe it is some working code which can get in people's hands, or perhaps just like a tech exploit to prove that we can actually solve a difficult technical problem. If all goes well there, we then graduate these projects into stage 3, and that will then have a dedicated team spun up. They will then be able to look at the product or the kind of EAP that we've created so far, generate a wider EAP, trying to get some people involved, and then assess whether we've got a good product and a good market and there's a fit there before we can kind of take that to market. And from there, we'll then get graduated into a main project. In terms of the outputs from our team, there can be quite a few different things. Obviously, some projects just get kind of left alone or delayed if there's not really much we've found there. But also things like acquisitions. So a good example of that is the data masker tools, which are available now, where we spotted that there was something our customers needed help with. We didn't have a solution for it, but there are already kind of well-known solutions out there that solve those needs. So we decided to acquire those rather than kind of build our own and get that value to our users quicker. Another one would be putting in a product feature. So we might decide that a project isn't viable on its own, but it might fit nicely into an existing product. An example of that is SQL Census, which we worked on a couple of years ago. That's now available to some extent in SQL Monitor in the server overview page for seeing permissions. And lastly, new products. So data catalog is a good example of that, and the most recent product, which has graduated from Foundry into the main product division. So the two projects that we've got going on in the Sharks team at the moment are estate management and Spawn. So I'm going to talk about estate management first, and then hopefully Chris will be available to jump in and talk more about Spawn. We'll have time for questions at the end as well, so please jump in and ask those as we go along. So in terms of estate management, it's something we've been working on for kind of 18 months now. We concentrated last year on one particular part of it, which was configuration. And this year we've taken a slightly different approach and want to cover a more broader area and different aspects of estate management, and hopefully bring those into a single tool and let then users or potential users guide what's actually going to kind of work in this sort of tool, what other capabilities that people want to be brought in, and then kind of add those and build up a tool that way. So we want to kind of go in the way that SQL Monitor has in the estate tables by providing some estate-wide views over certain different aspects of estate management. So giving you kind of everything in one go and then being able to drill down into detail rather than to look at the detail between individual servers and kind of make and connect those dots yourself. We also want to be able to track changes across the estate. So anything we're kind of displaying in the UI, we also want to be able to break that down and show you a history so you know when things have changed. So that can help you with your diagnosing issues or things like that. And there's kind of 5 or so areas of estate management which we want to build on and then get out into users' hands. So the first one is discovery. And while there are various different kind of technologies out there for discovery, we haven't really seen a popular one among the people we've spoken to, or something which kind of does the job fully for them. We spoke to people like Steve Jones, who told us that it was impossible to create a kind of 100% discovery tool, which we've taken on board. And while we are now kind of well aware that we can't absolutely nail and solve this problem for everyone, we think that if we create something which is really flexible in both the different types of discovery which you can do, so whether it's Active Directory or network or in the cloud providers, and combine that with a way of deploying it flexibly, so deploying different parts to do this discovery in different parts of your network, for example, and combining those all into one kind of main list of discovery, then we can actually add a lot of value to a lot of our customers, both for getting set up quickly and easily with our tool or other tools that we have, as well as finding servers as they get created. We've all kind of heard stories of people that are DBAs or DBA team lead that have been called in to help with a particular problem on a SQL server, but never really heard of that SQL server, didn't know it existed because it's been installed with some sort of third-party software. And if you talk to Grant, it's pretty much always Peggy from accounting that seems to install all this rogue software that installs SQL servers. So we want to be able to also allow custom kind of discovery schedules as well to be able to find those servers as quickly as you need. The next is inventory. So a lot of people we've spoken to, again, have got some sort of tool in place to help with inventory, whether it's a CMDB or an Excel sheet or something like that. But they do struggle with keeping it up to date and making it valuable, so it kind of gets out of date quickly and then doesn't really become that valuable resource which they want it to be. So we think we can combine the concept of kind of regularly updating properties from these different resources, such as the versions and the editions and such, and combining those with custom metadata provided by the user themselves, so whether that's kind of the business owner or SLAs, things like that, and putting that together to give some context when you are looking to diagnose a particular issue on a server or looking to migrate a server or anything like that. You've got some additional detail and some extra context there around what this server is kind of for and what's changed on it. We want to be able to make that as seamless as possible as well. So we're exploring kind of having some sort of rules. So when a new server is found, it can automatically be assigned to certain groups or tags based on that. So now the estate management tool is really going to be complete without a dashboard. Everyone likes or especially like the idea of a dashboard. So we want to play around with a few different ways of displaying information to make it useful for as many people as possible. And we think we can do that by having some kind of key or high-level insights along the top, so direct people into areas of their estate which they want to have a closer look. We can then display some kind of breakdowns of the estate based on versions or additions and things like that, so we can see different areas of their estates in different ways, as well as a kind of a long list of all the servers or all the resources in the tool, so you can filter and search and things on those. One thing we've tried to do is spend a lot of time looking at different workflows, so how people are working to do certain jobs in their estate or solve certain issues. And we've tried to create kind of different levels of detail from this dashboard down all the way to kind of a detailed server view. And allow you to jump between different sessions and switch context kind of as you're doing these things to make it easier and hopefully fit around the workflows you're used to rather than forcing something new on you. So the first of the kind of 3 capabilities we're looking at to add first of all is user access. I mentioned SQL Census earlier on, that it's now a part of SQL Monitor on the server overview. We want to take that a bit further and add some estate-wide views onto that technology. We found that a lot of people, while they can already kind of dig down into a server and see who has sysadmin access to it, I can't often then see who's in the individual Active Directory groups and other groups within that, so they have to then get other people involved. So we want to help solve that by giving a list of complete users, so propagating all the groups for you and showing that to you, but also being able to take a user at an estate level and say, tell me all the different servers that this particular user has access to, and be able to kind of bucket both users and servers by the amount of sysadmins they have or the amount of servers they have sysadmin access to. The next is configuration. So this is something we did work on quite a bit last year, but we've taken a couple of steps back and tried to, again, apply those estate management views or lenses to this. So being able to say for a subset of the important settings, show me all the servers, for example, which have CLR enabled or whatever that setting might be, and be able to show you which servers you've got in your estate which don't have the kind of recommended settings or the settings you've told us should exist or should be set for a number of servers. Obviously, you're always going to have third-party applications and such which need certain settings turned on or off, which might be against your best practice. So you also want to have the ability to override these settings and say for this particular server, this value should be X or whatever it might be, and then also allow you to kind of annotate and document that as well. So when you come back to looking at the server in 6 months or a year, or whenever that is, you've got a clearer picture of why these settings are set this way, so you don't kind of have to worry about figuring that out or worry what's going to happen if you set them back to a different way as well. And finally, maintenance. So the amount of databases that people have within their environments now are huge and kind of growing all the time. So keeping track of what databases are getting kind of maintenance and what is a difficult task. So again, we want to try and apply a statewide view to this to make it easier for people to spot which databases aren't getting the required maintenance or the maintenance they expect, as well as things across the servers such as community scripts, so who's got or which servers have Ola Hallengren scripts installed and which don't, and which parts of that, as well as looking at jobs across the estate as well. So if you've got a common set of jobs you expect to be across all your servers, are there any servers which are missing one or more of those jobs we can highlight for you as well? So that's a quick overview of the estate management project we're working at the moment. So our current status is that we are basically building the designs and the kind of snippets you've seen on the slides today at the moment, and also doing a lot of research as well. So we're talking to as many people as we can about the estate and the challenges they have managing that, and also getting feedback on those designs. So if there's something you'd like to get involved with, we've got an email address, which is estatemanagement@redgate.com. And also we'll be taking questions that I mentioned after this particular session as well. Hopefully now Chris is available. Chris, are you there?
Yes, I am. Thank you very much. Apologies for not being present right at the beginning. Let's see. So hopefully we should be on the Spawn slides right about now. So thanks, Matt. So Spawn is the second project that we've got in flight in the Foundry team at the moment. And this was really born out of some research that we started a little while ago now that we sort of titled The Future of Database DevOps. And what we did is we wanted to think about the landscape, both from the point of view of Redgate, so the kind of solutions or products that we have available, but also kind of cross-reference that to the industry trends at the time. And we drew out a load of different things. We considered different areas, things like rollbacks or testing in CI systems or provisioning as well. But what we settled on is we think that we could actually improve provisioning even more so than we've already got with something like SQL Clone. So if you're familiar with SQL Clone, it's a system that allows you to effectively create very lightweight copies of a database, and you basically create a snapshot of a known database state, and you can then spin up copies very, very quickly. Now, this has really helped to accelerate lower dev environments, so dev and CI systems. But what we recognized when we started this research is that there's been a lot of industry trends out there, sort of tending towards containerization and Kubernetes in particular, and the idea of sort of temporary environments. And we felt that whilst SQL Clone was able to make this much easier by spinning these large databases up very quickly, there's still more work to be done in enabling the database to be truly a sort of throwaway temporary thing that you spin up in CI systems or development environments. And so this is where Spawn came from. So Spawn really tries to marry those two things together. The technology in SQL Clone to allow you to spin up very quick copies of large data sets, but also tying that together with the ideas of containerization. So spinning up full instances on demand and then being able to throw those away afterwards when you no longer need them. And so Spawn really is just a software as a service that provides databases on demand for your development and CI workflows. So as I said, it really makes it easier to include the database in those dev environments and the DevOps pipelines. And the idea is that for every single time you need a database, you just spin up what we call a data container from an image that you've already created previously. And the idea here is it's self-service, and we encourage these to be throwaway. So for every sort of branch that you might be working on or every single CI pipeline that you need a database, you're encouraged to spin up a data container, connect to it, perform whatever actions you need, and then throw it away afterwards immediately once you're finished. The idea of it being self-service and automating these data containers means that you can actually work by yourself without interfering with other people. So these stories that we've heard about people with shared dev environments simply aren't a problem anymore. You can just spin up as many data containers as you need, indeed even for every single branch that you're working on in your dev environment, and use it and throw it away as needed. The other thing with Spawn is that it supports multiple database engines. So although we do support SQL Server, we also have support for MongoDB, Redis, and MySQL as it stands right now. And we're exploring the opportunities with different database engines as well. Obviously, it's fast and lightweight because we're using the same technology that SQL Clone is using under the covers, so differential volumes to make it very quick to spin up copies of these large data sets. And by combining it with containerization, we're able to spin these whole instances up very quickly and also tear them down immediately afterwards. And as I said, it's cloud-hosted and self-service, so there's no sort of long set of process to go through. You just ask for a data container, and sure enough, you get one back. But how do you actually get started with Spawn? So I talked about this idea of a data image, and this is very similar to how SQL Clone works. Effectively, you're going to have some state that you want to make available in your other environments. So this might be a masked copy of production, for example, and that might just be a backup file. Or indeed, you might even just have a set of SQL scripts that represent a useful state that you might want to make available for other people. Whichever format it is, you effectively take that state and upload it to the Spawn service. And from there, given if it's a backup, we'll restore that to a database engine and then take a snapshot of it. And then that will effectively bake a data image that you can then use later. Now, this is kind of your golden master copy of the state you want to make available. So from this, many different data containers can be copied from it. And again, because we're using similar technology to SQL Clone, they're very lightweight, so very quick to spin up. In terms of how to create those copies, the idea is that data containers, which come from that data image, are intended for a single user or single CI pipeline. So again, as I said before, you're encouraged to spin up as many of these as you need. And everything is driven through the command line because we want to make Spawn automation first. We believe that that's the best way to get this integrated in all sorts of environments, be it CI or dev environments as well. So if we take a look at a quick demo of this, this should be a video popping up shortly. So I can't see it on my screen. Here we go. So as you can see there, we've got a Spawn CTL command line. And what we're saying is I'd like to create a data container. And I specify an image. In this case, I'm just saying demo to do. And then what happens is behind the scenes, we'll talk to that service. And it will return me a connection string. Let's see if I can just get that back up again. So yeah, effectively, I ask for a data container from the service. It returns me a connection string, and then I can just use that connection string to connect to it, just as if it was any other sort of instance that I might have installed locally. And the idea here is that obviously for every time you need one, you just spin one up and off you go. You connect to it and use it just as you would normally. Now, the other thing we have with Spawn is this ability to make snapshots as you go through. So, for example, I have created my data container from a data image, and I've made some changes. Maybe I've introduced some new data, or I've reproduced a particular bug, and this is a good state that I don't want to lose. So from here, I can actually save the changes of this data container so that if I do something destructive and accidentally delete it, I can reset back to that state very, very quickly. So we'll show this in another demo here. So you should be seeing a video pop up, and we've got a terminal that's split in half. At the top, we've got a query window, and we're just going to select from a table that shows me a list of different data. And then I'm actually going to delete all of the rows within that table. So I'm going to lose, in this case, 615 rows. And you can see now that those have all disappeared. Down at the bottom in a separate window, I'm actually going to reset the data container back to a good state. So I just ask Spawn to reset the data container back to where it was before I did this delete. And if we jump back up to that top window, you can see that now all my data is back. So this really makes it much easier than going through the process of restoring a backup file. In order to get that data back, it's much quicker to just do it via a reset command. And of course, you can save the states as you go along, so you can reset back to whichever state you've decided is the useful one for you. The other thing with Spawn is that we want to encourage it from a team point of view. So although the data containers are intended for a single user, data images, i.e. that golden snapshot, can be shared with your whole team. So for example, if Matt's working on the same team as me, we can both have a similar data image that we start from, but our own independent copies of the data containers. The other thing that you can do with Spawn is, as I said before, you can save these snapshots as you go along. So if, for example, I manage to reproduce a bug in my copy of the data container, I can actually save the state of that data container having reproduced the bug. I can then graduate it into a data image and then share that with Matt as well. And then he'll be able to create his own independent data containers through which he can do his own exploration without worrying about affecting me or my data container. So really, that's all there is to Spawn. It's a hosted database as a service, effectively, but it comes with a bunch of different nice features. Again, playing on the technology of SQL clone underneath to make these copies very quick to produce, but also combining it with the ideas of containerization and Kubernetes that we've seen as a growing trend in the industry. But as I say, it's a research project at the moment. It's something we're actively engaging in and trying to build upon. If you're interested, you can go to spawn.cc, which is the website we have where you can read the documentation or you can read about the different stories that I've briefly touched on in this presentation. Alternatively, you can email spawn@redgate.com if you have any questions after this Redgate stream session. And that's all there is to it, I think. Again, the contact details are there for the estate management details that Matt's been running through. But I think we have about 5 minutes or so for questions at this point. So if Matt wants to come back in, hopefully we can field some of those.